Chapter 3, Approach to Solve Algorithm Design Problems. Approach to solve algorithm design problems. We will study an approach to solve algorithm design problems in this chapter. It's not so long chapter, it's really interesting. Introduction. Know the theoretical knowledge of an algorithm is essential, but it's not efficient. What do we need? We need to have a systematic approach to solve problems. Our approach is fundamentally different to solve any algorithm design question. Master this approach, I skipped a line, master this approach and you'll be better than most of the candidates in interviews. What's the approach proposed in this chapter? 5 steps for solving algorithm design questions. Constraints. Some organization call it requirement gathering stage. Idea generation. Some organization call it brainstorming. Complexities or challenges. Then at this stage we start writing the code, then test. And usually this goes back to phase 3 and keep going. Complexities, coding, testing. Sometimes they call it analysis, implementation, testing. Analysis, implementation, testing. Because it's a continuous process. And keep updating the application or the mobile app or the website is really essential to its success. Now, each one of these, let me go back, each one of these will be discussed in the rest of the chapter. All right? So constraints, solving a technical problem is not just about knowing the algorithms and designing good software system. What does it say here? Do not assume things. Ask the interviewer, for more details. Don't assume things. Even in work environment, do not assume things. You try to capture all constraints about the problem. Just know more, okay? So here, like few examples. Basic guidelines for constraints for an array of numbers. Ask these 4 questions. How many number elements in an array? Because array of 100 integer is different from a billion integer, right? What's the range of values in each element? What is the minimum and maximum values? What is the kind of data in each element? Is it an integer or a floating point? Does the array contain unique data or not? And all that stuff. Here is another example, practical example, and a basic guideline for constraints about an array of string. So we have 3 questions to talk if it's related to an array of string. How many numbers of elements in the array? Is it too long, too short? How many elements? What's the length of each string, each element? How big is it? What is the minimum and maximum length? Does the array contain unique data or not? And here is a basic constraints for a graph. We'll go through it and that's it. We are done with the first section. The basic guidelines for graph. Basic guideline for the constraints for a graph. How many nodes are there in the graph? See how many. How many edges? Is it a weighted graph, like the path? The edges are weighted. What's the range of weights? From what to what? Is the graph directed or undirected? It has a flow direction or it's bidirectional always. Is there a loop in the graph? That's important, a loop. Is there negative sum loop in the graph? Does the graph have self loops? All right. And that was the first part, the idea generation, or some organization called brainstorming. Here, we need to analyze the problem because the interviewer may modify a question a little bit and the approach to solve it will vary. Well, how to solve a new problem? How to solve a new problem? Consider your options. It says consider just like that. The following is the strategy you need to follow to solve an unknown problem. Try to simplify the task in hand. Break it into smaller pieces. Try a few examples. Think of a suitable data structure. Think about similar problems you have already solved. All right? And each one is covered here. Try to simplify data in hands. Try a few examples. Think of a suitable structure. Pick one solution from the many options you have. Examples are given here. All right. Complexities. We talked about the constraints, which is similar to the information gathering stage. We talked about the idea generation, similar to the brainstorming, and we reached the level where we selected one of the ideas. Okay, solving a problem is not just finding a correct solution. All right, the solution should be fast and should have reasonable memory requirement. You have already read about the big O in the last chapter, right? We read about the big O, the theta, the omega, and all this stuff. You should be able to do big O analysis. In case you think the solution you have provided is not that optimal and there is some more efficient solution, then think again and try to figure out this. Most interviewers expect that people that interview you expect that you should be able to find the time and space complexity of algorithms. Time, space, all right? You should be able to compare time and space complexity instantly. Whenever you are solving, this is about the complexities, all right? You should be able to find the time and space complexity. Whenever you are solving some problem, you should find complexity associated with it. From this, you would be able to choose the best solution. So this helps you in choosing the best solution among the ideas being generated previously. In some problems, there is some trade-offs between space and time complexity. So you should know these trade-offs, like either or, competing goals, right? Sometimes taking some bit more space saves a lots of time and make your algorithm faster. Sometimes if you sacrifice some more space, it will be way faster, okay? After the first three stages, the constraints, the idea generation, and the complexities, now we reach the fourth option, which is coding. Now we start writing the program. Unlike so many programmers, they start writing the program from the first stage. No, all these previous three stages are required. This is the fourth stage. At this point, you should be able to do the final coding. Never jump into coding before discussing constraints, idea generation, and complexity with the interviewer. Never. The interviewers love that. All right. We are accustomed to coding in an IDE like Visual Studio. So many people struggle when asked to write code on a whiteboard or some blank sheet. Therefore, we should have a little practice to the coding on a sheet of paper. You should think before coding because there is no back button on a sheet of paper. Always try to write modular code. This is a golden advice. Always try to write modular code. Small functions need to be created so that the code is clean and managed. Clean and managed. All right. If there is a swap function, so just use this function to tell the interviewer that you will write it later. The very final stage is the testing. Once the code is written, you are not done. You need to test. Test smaller pieces before bigger pieces. Always test. There are 3 types of testing. The normal test cases, like normal ones, the age case tested, like the extremes, all right, like here, and as an example, for the same linked list algorithm, age cases may be how the code behaves when an empty list is passed or just one node is passed. This is called the age, like the extremes. In the previous example, for example, if we are going to write some algorithm, let me highlight it here. If we are going to write some algorithm for linked list, then this may contain what will happen when a linked list with 3 or 4 nodes is given as an input, like normal. All right. So this is the normal test cases. This is the age. And the load is just make it full as much as you can, like increase the number and see what happens. What's the performance going to happen? As the memory get used, something get crashed, yeah, just like that. All right. And we have an example here that we are going to apply all the first 5 stages, all the 5 stages we just talked about. What are the 5 stages before we start reading the example? What are the 5 stages? Number 1, constraints. Number 2, idea generation. Number 3, complexity. Or number 4, writing the code or coding. Number 5, testing it. All right. These 5 stages are similar to the app development cycle when you try to develop an application. Well, no matter if it's a desktop application or a web-based application or a mobile app, it's the same. Let's see this example. Let us suppose the interviewer asks you to give a based sorting algorithm. Some interviewee will directly show the quick start O and log n. Oops, mistake, you did not. You need to ask many questions before jumping to solve this problem. Just gather more information, then give several options, do brainstorming, then do the complexity analysis, then choose one, then start coding, and then do testing. Question 1, let's go through with this example, all right? Example, let's suppose the interviewee about the best sorting algorithm. That's the question. What is the best sorting algorithm? All right. Question 1. What kind of data we are talking about? Are they integers? The interviewer will say, yes, they are integers. Question 2. How much data we are going to sort? Answer, maybe thousands. Question 3. What exactly is this data about? They stored person's age. Now we know the range. It can be negative, all right? What kind of data structure used to hold this data? Data are given in the form of some array. Can we modify the given data structure? No, we cannot modify the data structure provided. Okay, from the first answer, we will deduce that the data is integer. The data is not so big. It just contains a few thousand of entries. The third answer is interesting. From this, we deduce that the range of data is 1 to 150. Data is provided in an array. From the fifth answer, we deduce that we have to create our own data structure and we cannot modify the array provided. Finally, we conclude we can just use bucket sort to sort the data. The range is just from 1 to 150, so we need just 151 capacity integral array. Data is under thousands, so we do not have to worry about data overflow. We get the solution in linear time. That's the answer. We will read sorting in the code in the coming chapters. All right. Chapter summary. At this point, you know the process of handling new problems very well. How to handle new problems, you go through these 5 stages. All right. In the coming chapters, we will be looking into various data structure and problems. They solve a huge number of problems are solved in this book. However, it is recommended to first try to solve them by yourself and then look for the solution. Always think about the complexity of the problem. In the interaction, interaction is the key to get problem described completely and discuss your approach with the interviewer. So do not start solving before fully understanding what is required. What is required? Go through these stages. And we'll do chapter 4 in a different video.